Today I'm going to be reviewing the PowerUrus 12.8 volt 100 amp hour lithium iron phosphate battery. And also later on I'm also going to do a tear down and show you what's inside the battery. Let's get started. First of all, dimensions: 13 inches by 9 inches by 6 3/4 inches. It weighs 29 pounds or 13 kilograms. This battery has a strap that goes all the way around the bottom of the battery, and that is more secure than just a strap that hooked up on the top of the battery. On the top we have a small vent to vent out any gas inside the battery to release the pressure. I have charged the battery to 100%. Let's go ahead and do a discharge test. And we're discharging at 10 amps. It's going to take about 10 hours to finish. Alright, it has been 4.5 hours. Capacity 46 amp hour. Voltage 12.7 volts. It's going strong. We are 9.5 hours in. Capacity 95.5 amp hour. 12.2 volts. We're getting there. I've got everything recorded down here. Alright, we made it. It's been 10 hours exactly. Capacity 100 amp hour. Voltage 11.6. It's still going. I'm just going to let it run until the BMS shuts down. The BMS just shut down. Battery voltage is 176 millivolts. Let's see what we got here. Total time 10 hours 16 minutes. Capacity 102.9 amp hour. So that's a little bit over the rated capacity for this battery. Here is all the data I have collected, and here is the beautiful discharge curve. It's time to charge the battery back up. Right now the BMS is turned off. The voltage of the battery is 3.8 volts. Usually you have to raise the voltage battery by connecting this battery to another battery in parallel. Otherwise your charger won't recognize the battery and it won't charge the battery. But with this charger here, I don't have to do that. I just plug it straight in there and it will charge the battery. Here we go. Just like that. 11.6 volt charging at 25 amps. I got two chargers here, so I'm gonna connect the second charger as well. Here we go. We're charging at 50 amps. It's time for a load test, but first let's hook up the inverter. To prevent spark, I use a resistor. Last time I used a 1.2 kilo ohm resistor. It didn't turn out well. The resistance is too much and the time I put on it is too short. So it still sparked pretty bad on my terminal and made a hole in the terminal. This time I'm going to use a lower value resistor. 2.2 ohm to be exact. Here we go. And make sure that I give it enough time to charge the capacitor. Alright, capacitor should be charged. Let's see what we got. Here we go. No spark. So let's turn it on. I got my heater ready. It's a 1500 watt heater. It's got two levels. Low is 800 watts, which is 80 amps out of the battery. High is 1500 watts, which is about 150 amps out of this battery. Alright, let's turn it on low. 40 amps. 50. 60. 70. 80, 88, 89, 90. Going down. When it's hot enough, it will go down. We got about 81 amp continuous. All right, it's been running for about 5 minutes and it's steady at 80 amp continuous. Everything is nice and smooth. After the initial test, I've done 2 more tests, one at 147 amps and one at 160 amps, and so far it has survived everything I throw at it. I want to see the limit of this battery, and if you read on the case of the battery, it says max discharging current 200 amps for 5 seconds. Let's go ahead and test that. Let me show you my setup here. Because I have to push over 200 amps and my inverter is only 2000 watts, so that's over the maximum limit of my inverter. So I have two 2000 watts inverters connected to the same battery. I've got a 1500 watt electric kettle which is powered by the top inverter. The 1500 watt heater is powered by the bottom inverter. Here we go. That is the electric kettle on, 148 amps, 146 amps. Let's turn on the heater. 180, 190, 200, over 200 amps now. And it's complaining, both of them complain. The battery voltage might be too low. We're at 230 amps. Let's see how long it takes. Yep, it shuts down. The BMS just shut down. You can see the voltage now is 1 volt. Let me turn this off here. Let's see how long it takes to turn back on. So let's put the timer on here. It's been over 15 minutes and the BMS does not turn back on. You can see the voltage is 1.5 volts. And if I try to turn on the inverter, nothing happens. So let's wake up the BMS by hooking up the battery to a DC power source. I'm using a 12 volt AC adapter here. It is 12.2 volts DC. I'm just going to hook up the 12 volt DC from the adapter to the battery in parallel. Here we go. 9 volt, 12. Here we go. Battery 13.19 volts. So the BMS is waking up, but only after I hook up a small 12 volt AC adapter. Let's try and turn on the inverter. Here we go. We're in business. So to sum up, this battery works fine for anything below 200 amps. But when you go over 200 amps, the BMS will shut down after 1 minute. It says on here on the label of the battery 5 seconds, but it's actually 1 minute according to my test. And then after that, the battery BMS will remain off and it will not turn back on until you wake it up with an external 12 volt DC power supply, either using a small AC to DC power supply or a 9 volt battery or a 12 volt battery. It's time for a teardown. Let's go ahead and remove the top cover and see what's inside the battery. This thing is a tough nut to crack. I already cracked the plastic. So let's go for a plan B. I finally got the top cover out and check out the glue they use. This is hard glue. It's hard as a rock. My first impression when I first opened up the battery, this is very nice. All of the cables are wrapped in some kind of special electrical tape. The main terminals are protected by some very thick and flexible silicon insulator. The entire battery pack is glued to the bottom by silicone. Let me see if I can show you down there. That stuff there on the bottom, that is flexible silicone, and it goes all the way around the bottom. And that's why I cannot take everything out without breaking the plastic case. We got 4 prismatic cells here, and they are all welded together at the terminal. That is a very secure weld. There are no stickers or labels on the cells, so I cannot tell what brand it is, but they look pretty nice. All 4 cells are strapped together by this steel strap, and there's an insulator where it's in contact with the cell. We got 2 very large aluminum heatsink on both sides of the pack. There's also a heatsink on the bottom of the BMS, and that heatsink is connected to the battery heatsink by this metal bracket here. So they are all connected together for heat distribution. There's also a very large heatsink on the top of the BMS, and that heatsink goes from here all the way to the bottom. We got the grayish silicon compound on the bottom of the battery, but that's only about ½ an inch thick. It doesn't get onto the heatsink, so it doesn't interfere with the heatsink of the BMS. Now let's take a look at the BMS. You got a heatsink on the top of the BMS, and then another heatsink on the bottom of the BMS. That heatsink on the top is quite thick. In fact, it's the biggest BMS heatsink I have ever seen on a 12-volt lithium iron phosphate battery. Also, this BMS is rather large. It occupies the entire side of the battery, so it goes from here to here all the way down to the bottom. Usually most of the BMS is only about half the size. This one is twice the size as other BMS. There's even a 3-volt lithium coin cell in there. I don't know what that's for, but that's something that you have to keep in mind, because sometime in the future you might have to replace that battery. There are some writings on the BMS. Let's take a look. I see LiFePO4 SPB19 TiO4. That is the part number of the BMS. I did a Google search, but it didn't come up with anything. But we know that it's made by LiFePO4. LiFePO4 is a more expensive brand that makes bigger and more expensive battery packs. This looks like a quality built BMS, and it doesn't look like any other BMS that I have ever reviewed before. Let's take a look at the connectors here. This is the balance connector, and next to it, this is for the heat sensor, and there are 4 pairs of wires on here. 2 pairs go to the main terminal. So this is one heat sensor here, right on the part where they crimp the wire. That is for the heat sensor on the top here, and on the bottom is a main battery wire. And we got the same thing for the positive terminal. When the battery gets hot, it's not just the cells that get hot, the wires also gets hot. And the best place to mount the thermal sensor is right here at the main terminal. So we got a total of 4 heat sensors. 2 of them go to the main terminal. The other 2 heat sensors go on top of the cells. Well, I'm trying to remove the heat sensor here, and it's actually on the welt on top of the cell. So it's kind of on the cell, but it's on the terminal of the cell. Let's go ahead and test the heat sensor. First test is cold temperature charging protection test. It should stop charging when it's cold enough, so let's go ahead and plug it in. All right, we're charging at 25 amps, 13.5 volts. Let's see what we got. There we go, it stopped charging. You see 14.78 volts, that because it comes from my charger. Now, if we let it warm up, let's see if it would resume charging when it's warm enough. There we go. It's resumed charging when it's warm enough, so it's working great. Next is the heat test. Let's see if it would turn off when it's hot enough. There we go, it turns off when it's hot enough. What I also want to know is, does it also turn off the output from the battery when it's hot enough? So let's go ahead and unplug the charger. I have my 12 volt light bulb connected to the main battery terminal. Let's see if it will turn off the light bulb as well. There we go, it turns off the output from the battery. Let's see if it would turn back on. It's been about 5 minutes and it does not turn back on. This is way cool enough. So I'm going to wake up the BMS by connecting it to a 12 volt external AC to DC adapter. Well, it didn't wake up. And then I realized that the light bulb is still connected to the battery output. So I disconnected the light bulb, and after 2 minutes the BMS woke up, and you can see the voltage now 13.4 volts without having to connect a DC power source. So remember this, in order for the BMS to wake up, or for you to wake up the BMS, you have to disconnect the load first. So there you have it. This battery passed every test I throw at it. The build quality of this battery is top notch, and they pay attention to every detail, especially the heat management aspect of this battery. And there's even a vent hole on the top to allow some heat to escape. That's awesome. And even the BMS comes from a more expensive brand. You got 4 heat sensors on this battery, whereas most batteries only have 2. And I think the reason why this battery can handle a lot more current than many batteries with the same capacity, and that's because of the heat sinks they have on here. I have never seen batteries of this size carry so many heat sinks inside. Even has a vent hole for the heat to escape. Right, it's time to glue the case back together. I'm going to use my homemade glue. It's a secret blend, but I'm going to put the link down in the description of how I made this. This is a heavy battery, so I'm going to need between 3 to 5 cc, so that's about between 1 to 2 of the syringes. Now we are just gonna close it. I'm just gonna let it dry for a few hours and see if it works. I let the battery dry overnight. Let's see what we got. The original strap goes around the battery and it's supported all the way from the bottom, so I cannot test the strength of the glue with this strap. I'm going to use a shorter strap instead. This strap comes from another battery, and it will hook on just the top part of the battery, and that will let me test the strength of the glue because it only pulls from the top. But first, let's check out the part where I glue the two halves together. It looks like it's being welded together. Very cool. Here is the part on the side of the battery. And the glue is rock hard. Ready to place a bet. Here we go. It's quite heavy. Almost 30 pounds. Oh yeah, that's not coming out. That's all I have for now, folks. Thanks for watching, and I will see you in the next video.